All right. And like I said, we're going to go ahead and finish up chapter 5. So we're going to cover 5, 6, 5, 7, and 5, 8. So as a quick recap, okay, factoring in general is undistribution. So if I told you to factor 6x squared plus 36x, okay, what we're looking for, is there something I can divide out of both of those? Okay, we covered this last time. So again, when you have a greatest common factor, you can divide both of the big numbers by 6. And when you have a variable common to both, we can factor out the one with the smallest exponent. So we can factor or divide out a 6x. And if we divide that out, we would be left with 6x times x plus 6. So again, factoring is undistribution. Okay. This is important because this is going to pop up pretty much in all of those sections. If there is a greatest common factor other than 1, we need to factor that out. Okay. The directions for all of these next few sections are going to say something to the effect of completely factor. That means to break up as much as possible. And that's like we said. So even though you could factor a 2 out of this, we need to take out the greatest common factor of 6. And if you forgot to factor out the x, you got to make sure and do that. So anyway, we want to completely factor this as much as possible. Okay. 5, 6 deals with factoring trinomials. Okay. So I'm going to show you the kind of the forwards way and then actually what we're doing. So if you'll remember, if I told you to multiply two x plus 3 times x plus 3. Okay, this is multiplication, this is distribution. So again, we're going to work backwards off of this, but just as a reminder. So if I told you to multiply these two things together, okay, you have to distribute. So 2x times x is your 2x squared. 2x times 3 is your 6x. 3 times x is your 3x. And 3 times 3 is 9. Then we would look for any like terms that we can put together. And we would end up with 2x squared plus 9x plus 9. So if I told you to multiply this, okay, this is what you would start with. This is what your answer would be. Okay, like I said, tonight in 5, 6, we're actually going to work that backwards. So you're going to start with the trinomial and you're going to end up with the sets of parentheses. So we're going to, again, factor. We're going to take this 2x squared plus 9 and we're going to break it up. Okay, and we're going to learn how to make it equal this. Okay, so 5, 4 was multiplying those two things together. 5, 6 is going to be undoing that. We're going to be taking our trinomial and then breaking it apart. Okay, we're going to start with some of the easier ones. Okay, and then we're going to get to some of the more difficult looking stuff. They throw you a couple of curveballs that I want you to be ready for. All right, so 5, 6, factoring trinomials. And really, these break into 2 main categories. Sorry that I lost focus there for a second. So, okay, so factoring trinomials is going to factor into or break into 2 main categories. For example, x squared plus 6x plus 8, or they may give us something like 3x squared plus 10x plus 7. And at the surface, those look kind of the same, but you're going to factor them differently based off of whether or not there is a number here. It's called a leading coefficient. Okay. When the leading coefficient is 1, or if they don't put 1 there, it is a much easier problem to do. And I'll talk about why. Whereas when they put a leading coefficient, this becomes more problematic. Okay. So there's really going to be 2 different methods to doing this based off of whether or not there's a number in front of your quadratic, your squared variable. It doesn't always have to be x. I like to use x. my math lab throws in A's or C's or Y's. They throw in all kinds of different variables. But anyway, so when there is not a leading coefficient. So these are the easiest problems to solve because the only thing we can multiply to get x squared is x and x. Okay, so really to factor this, all we have to do is figure out specifically what two numbers will multiply to get 8, but they also add to get 6. Okay, and that's going to be the numbers that are going to go here and here. And the easier way to do this is to deal with the multiplication, because as far as adding, there are a gajillion numbers that add to get 6. You can add 5 and 1, or 3 and 3, or 7 and -1, or 100 and -90 or 94. Okay, so there's too many addition problems that equal 6. However, if we're talking whole numbers that multiply to get 8, it's either 1 and 8 or it's 2 and 4. Okay, because again, we're looking for whole numbers that multiply and then add. So this gives us a smaller group to look at. So if we're looking 1 plus 8 is 9, well, that's not it, but 2 plus 4 is 6. So 2 times 4 is your 8, 2 plus 4 is your 6. So then your factors are x plus 2 and x plus 4. We'll do a few more problems with no leading coefficient, because really there's only a couple of things they can do to kind of make this tricky. Okay, so if they want us to, again, they'll say to completely factor. Okay, so again, we're looking for what we can break this up into. And again, when there's no number in front of your squared variable, this is a fairly simple problem because the only thing I can multiply to get a squared is a and a. And then again, I'm looking for numbers that multiply to get -48. That will also add to get 13. Now, here's one of the curveballs that they may throw at you. If we're multiplying to get a -48, what kind of numbers multiply to get a negative? Okay, one positive and one negative. So when we write down our factors of 48, like 1 and 48, we need to make one of those numbers negative. 48 is also -2 times 24. 48 is 3 times 16, or 4 times 12, or 6 times 8. And if you're not sure where I got these numbers from, again, they're just what multiplies to get 48. It's really easy to do with your calculator. If you just take 48 and divide it by 2, if you get a whole number, then those are your factors. Like if you type 48 into your calculator divided by 3, you get 16. Those are your factors. 48 divided by 4 is 12. If you type in 48 divided by 5, you get a decimal. So 5 is not a factor. But 48 divided by 6 is 8. 48 divided by 7 is a decimal, so it's not. And obviously, if we get to 8, then we're going back through this same list. So anyway, that's my list of factors. This is all the numbers that multiply to get -48. And then we're looking for the one, the group, okay, that adds to get 13. Okay, nope, 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 nope. Yup. Okay, -3 plus +16 is the only pair that's going to add up to get 13. And order doesn't matter, so I would do a minus 3 and a plus 16. Okay, So that's pretty much it. Now, there is one other thing they can do that looks like a leading coefficient problem, but really ends up being one without a leading coefficient. For example, if they give us something like 3x, pull this up here. So 3x squared minus 18x plus 27. Okay. We do have a number in front of our x squared, but if you look at this problem, what do these all have in common? What can I divide out? Okay. We always want to look for a greatest common factor. Now, the first problems, we can't factor anything out of 1x squared, like we can factor out an x, but this one doesn't have an x. So there is no greatest common factor here. But when there's a number in front, I want to look and see, wait a minute, are all of these things divisible by something? And in this case, yeah, they're all divisible by 3. So if I divide that 3 out, I'm left with x squared minus 6x plus 9. So now I can factor this with no leading coefficient. I just want to see if this x squared, negative 6x, and positive 9, okay, will break down anymore. So 3 is still a greatest common factor, so it's part of the problem, or part of the factored form. And then we want to see if we can factor this piece, this x squared minus 6x plus 9. So again, x squared is x times x. And again, then I'm looking for two numbers that multiply to get positive 9, that add to get negative 6. Okay, multiply to get 9 is 1 and 9, or 3 and 3. But wait a minute, we need to add this to get a negative 6. 1 plus 9 is 10, 3 plus 3 is positive 6. So that doesn't quite work. But that's another trick we have here, okay? If it multiplies to get a positive, you can either multiply two positive numbers together, or you can multiply two negative numbers together. Okay, if we multiply negative 3 times negative 3, that also gives me a positive 9. And now if I add negative 3 and negative 3, that's what gives me my negative 6. So this is my completely factored form. Now, don't forget, when we factored that 3 out, that's part of the completely factored form. So if you factor out a greatest common factor, it needs to stay with your factored form. Okay, the last thing they can do with no leading coefficient, and this kind of, I don't want to say it irks me, but anyway, it's one of those things where they'll throw a couple of problems like this in just to kind of mess with you. Okay, so say we have to factor x squared plus 3x plus 1. Okay, x squared is x times x. But if we look for numbers that multiply to get 1, that also add to get 3, there aren't any. 1 is only 1 times 1, but if you add those together, you get 2, not 3. So we don't have any terms that multiply to get 1 and add to get 3. So this one is not easily factorable, or we just say that this problem is prime. They don't throw very many, but they do throw a couple of problems in there that are prime. They don't easily factor. Now, we'll talk about being able to force factor something, but anyway, that's beyond the scope of this lesson right here. So, again, when there's no leading coefficient, okay, the variable part is easy, just that. Then you're looking for two specific numbers that multiply to get your last term, that add to get that middle term. And that's what we're looking for. Okay. If there's a leading coefficient, look to see if there's a greatest common factor. If there is, keep that with your problem. Now, when there is a leading coefficient and we can't factor it away. All right, so if we're going to factor 3x squared plus 10x plus 7. Okay, a problem like this, we have two options. Option number one, this is what I was actually taught way back in the day. I had a sadistic math teacher that just kind of liked this, I don't know, to have to do a whole bunch of extra work. So you can do what we call the old guess and check method. Some students like this because they're usually pretty good at it and they can make it work in their head. Other students absolutely hate this because you can do a bunch of work and still not end up with the right answer right away. Anyway, so because there's a number in front of the x squared, we can't just automatically grab x and x. Okay, so what happens is we've got to figure out what can we multiply to get 3x squared. Now, in this case, it's either 3x and x or x and 3x. Okay, now if there are more factors, like if this would have been 8, you could have 2 and 4, you could have 8 and 1, you could have, anyway, the more factors there are, the more possibilities there are. Okay, similarly, okay, we got to figure out what are the factors of 7. We could do 1 and 7, or we could do 7 and 1, or 1 and 7. Same thing, we could end up flipping them around. We can mess with that. Okay, and then we just got to see which one of these would actually yield the correct trinomial. Okay, for example, if we multiply this one out, okay, 3x times x is 3x squared. 3x times 7 is 21x. 1 times x is 1x. 1 times 7 is 7. So this gives you 3x squared plus 22x plus 7. Okay, we need to get a 10 here. We got a 22 here. So this one is not the right answer. Okay, we multiply this one. 3x times x is 3x squared. 3x times 1 is 3x. 7 times x is 7x. 7 times 1 is 7. If we add those, we get 3x squared plus 10x plus 7. Wait a minute, that's the right answer. This is the right factor. Okay, so that's what we call the guess and check method. Again, depending on how many factors there are, you could end up having to guess a whole bunch of different possibilities before you find the right answer. Now, some people are good at putting numbers together in their head and they can do this really quickly. If you're that person, great, do it that way. If not, I'm going to give you another method that's much more straightforward that always works. It's a bunch of steps, okay, but it always works. Okay, so I'm going to take that same problem, 3x squared plus 10x plus 7, and I'm going to factor this using what we call the AC method. Okay, the AC method is it's also called the British method. Okay, it's a way, step-by-step method for factoring this. Okay, there's a few steps, so just kind of follow with me, but the good news is this is all being recorded, so you'll have access to it and you can go back and rewatch it again. Okay, the first step is we're going to multiply what we call A and C. So standard form of a quadratic equation is ax squared plus bx plus c. So if I refer to A and C, A is just your first term, okay, C is your last term, B is the middle term. Anyway, so we're going to multiply A and C. So if I multiply 3x squared and 7, I get 21x squared. So step 1 is to multiply A and C. Step 2, okay, we're going to find factors or what multiplies to get that 21x squared, but also adds to get your B term or that middle term, that 10x. So what can I multiply to get 21x squared that I can also add to get 10x? So 21 is 1 and 21, or 3 and 7. And of course, to get the x squared, you need x's. So 1 and 21 adds to be 22. That's definitely not it. But wait a minute, 3x plus 7x. Aha, that is my 10x. Okay. Then what we're going to do is take our 3x squared plus 10x plus 7, but instead of 10x, we're going to use my two new terms, my 3x and my 7x. And then we can factor this by grouping, which we learned last time. So if I look at just this group, I can factor out a 3x, leaves me with x plus 1. If I look at this group, I can factor out a 7, which leaves me with x plus 1. And then look, x plus 1 is now my greatest common factor. So x plus 1 is my greatest common factor. If I divide him out, that leaves me with the 3x plus 7. So that would be my completely factored form. Okay, it's basically 4 steps. I get it, it's kind of confusing, but the good news is it always works and there's no guess and check to it. You're just finding the right problems or the correct factored form. Okay, I will do 2 more examples just so you have those to kind of go back and revisit, but I want you to be able to see a couple of different examples here. Okay, so if we want to factor 8x squared minus 14x plus 3. Okay, again, guess and check. 8, you can multiply 1 and 8 or 2 and 4. So that just gives you more possibilities to have to guess and check, which isn't very fun. I like having a more direct way to do this. So again, I'm going to factor using the AC method. So I multiply A and C. So 8x squared times 3 is 24x squared. Then I'm specifically looking for what I can multiply to get that 24, but also add to get that negative 14. So 24 is 1 and 24, or 2 and 12, or 3 and 8, or 4 and 6. Now I need to multiply to get a positive 24, but I need to add to get a negative 14. So I need both of these to be negative. Nope, nope, nope. Yep. Okay, so negative 2x and negative 12x multiplies to get positive 24x squared, and negative 2x and 12x, or sorry, negative 2x and negative 12x add to get my negative 14. So that's what I'm going to use in place of the 14. So I'm going to use negative 2x and I'm going to use negative 12x. Then I'm going to factor by grouping. With this group, I can take out a 2x, leaves me with 4x minus 1, negative 12x and 3. If I factor out a negative 3, that's going to leave me with 4x minus 1. And if those are the same, that's my greatest common factor. So I get 4x minus 1 times 2x minus 3. That is my completely factored form. All right, I do want to do one more example of those. And to me, this is kind of the ugliest problem that you're going to have to deal with within this section. All right, if they give us something like this. So we've got 12 x to the fourth plus 30 x to the third plus 18 x to the second. All right, big numbers and x's all over the place. So remember, the first thing we want to look for, can I divide something out of all of these? And anything you can divide out is good, but if we can factor our biggest factor or the greatest common factor out, that's going to make these numbers much smaller and easier to work with. For example, 12 and 30 and 18 are all divisible by 6. And they all have x's, so I can factor out that smallest exponent. I can actually factor out an x squared. So if this is my original problem, 12x to the fourth plus 30x cubed plus 18x squared, I can factor out a 6x squared. And if I do that, I'm left with 2x squared plus 5x plus 3. Remember, divide. So 12 divided by 6 is 2. When you divide variables, you subtract the exponents. So that's why x to the fourth divided by x squared is x squared. 30 divided by 6 is 5. Subtract your exponents. 3 minus 2 is 1. 18 divided by 6 is 3. Subtract your exponents. That gets rid of my x's. Okay. Now, this 6x squared is going to stay part of my completely factored form. And I've just got to factor this 2x squared plus 5x plus 3. Now, again, there's a number in front of the x squared still, so I need to do my AC method. So I'm going to multiply a and c. Then I need to figure out what multiplies to get positive 6. That's also going to add to get 5. That's going to be 1 and 6. Or 2 and 3. 1 plus 6 is 7. So I'm going to use the 2x and the 3x. Okay. So 2x squared plus 2x plus 3x plus 3. Again, I replace my middle term with my new terms and then factor by grouping. Well, here I can take out a 2x. Leaves me with x plus 1. Here I can take out a 3. Leaves me with x plus 1. So that x plus 1 is my greatest common factor. If I divide him out, I'm left with 2x plus 3. And then this is the completely factored form. So when there is no leading coefficient, okay, the problems are much simpler. All you got to do is come up with what multiplies to get 8, it adds to get 6, and write those numbers down. Okay, there's your completely factored form. When you do have a leading coefficient, okay, step 1, look for a greatest common factor first. Okay, but if there isn't a greatest common factor, or if you still end up with a leading coefficient, you either need to factor by guess and check or using that AC method. Again, the steps are multiply A and C. Okay, that was the 2x squared and the 3. That's where we got this 6x squared. Then you want to find factors of that number, your AC number, that also add to get your middle term, that B term. Okay, then we replace the B term with our factors and then factor by grouping. Okay, so it's basically 4 steps. It's kind of a convoluted process, but it does yield an answer without having to do any kind of guess and check. All right, 5-7 is all about factoring squares. Okay, So 5, 7 is convenient. So there's a couple of trinomials. So they'll give you something like x squared plus 6x plus 9, which we can factor in the same method. Okay, so x squared plus 6x plus 9. X squared is just x and x. 9 is 3 times 3. That also adds to get 6. So there's my terms. The thing that makes this different is because these two terms are the same, x plus 3 times x plus 3, you can either write it like this or that, x plus 3 quantity squared. My math lab actually takes either. So technically this isn't learning anything new. You can factor this in the exact same way we did the previous section, okay, and write it as 2 separate factors, or once you have it factored, you can write it as 1 quantity squared. Good news about 5, 7 is if they give you a ugly problem like 4x squared plus 4x plus 1 in this particular section, okay, you don't have to factor this one by the AC method because again, you know you're going to end up with squares. You know both of these parentheses are going to be the same. All we have to figure out is what can I multiply by itself to get 4x squared. Okay, that's 2x and 2x. And then what can I multiply by itself to get 1? That's 1 and 1. So then that's your factored form. Or again, you can write that as 2x plus 1 quantity squared. Now, the one new thing is if they give you something like this, x squared minus 9. This is a difference of perfect squares. And it's basically the same thing as saying x squared plus 0x minus 9. So basically this middle term is a 0. That's why you don't see it. It looks like there's just 2 terms. But what it is that middle term is a 0. So what you're looking for is what multiplies to get negative 9. That's going to turn around and add to get 0. And again, the only thing that'll add to get 0 are opposites. So it's going to be the same number, just one's going to be a positive and one's going to be a negative. So 9 is 3 times 3. Just one of them will be positive, and then one of them will be negative. So if we work this backwards, so if I show the multiplication, okay, x times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is negative 9. If we combine those middle terms, they basically go away. So when you have a difference of perfect squares, it's basically just what can I multiply to get x squared? X and x. What can I multiply to get 9? 3 and 3. Just make 1 plus and 1 minus. Okay, so instead of putting the 0 and then working the whole thing through, you can actually kind of shortcut this, which is nice if they give you something gross like 25a squared minus 36b squared. Instead of putting a 0 here in the middle and doing the AC method where we got to take 25 times negative 36 and then figure out what, anyway, doing that whole process with some really big numbers, okay? If this is a perfect square, meaning I can multiply something times itself and get this, and this is also a perfect square, and it's a subtraction, okay, then all I have to do is, okay, what multiplies to get 25a squared? That'd be 5a and 5a. What can I multiply by itself to get 36b squared? That would be 6b and 6b. That's a 6. And then just make 1 plus and 1 minus. And that would be your completely factored form. Now, like I said, they love to throw curveballs, so they will do a couple of things with this. Thing number one is the same typical curveball that you're going to see over and over and over again. Okay. If they give you two numbers that are not perfect squares, or they might even be perfect squares, always, always, always look for a greatest common factor first. Okay. Looking at this particular problem, 2a squared minus 18, what can I divide out of both of those? Okay, they're both divisible by 2. So I can divide that 2 out right off the bat, and that leaves me with a squared minus 9. Now a squared is a times a, 9 is 3 times 3. Because that's minus, I can do 1 plus and 1 minus, and I end up with my completely factored form. So the first curveball is they'll throw you something out there that might need to factor out a greatest common factor. Curveball number next is they may give you a problem that you'll have to factor more than once. Oops. It's got to be a minus. Okay. For example, if they told you to factor x to the 4th minus 16. Okay. X to the 4th minus 16. Well, x to the 4th is x squared times x squared. 16 is 4 times 4. Make 1 plus and make 1 minus. That's a good factored form. But if we look, x squared is a perfect square. That's x times x. And 4 is a perfect square. That's 2 times 2. Okay. So the plus 1 doesn't factor anymore. There's nothing that multiplies to get positive 4 that adds to get 0. So this one actually stays. But the minus 1, we can actually break up again. X squared is again x times x. 4 is 2 times 2. Make 1 plus and 1 minus. Now, these don't break up anymore because x doesn't factor anymore. And you can't multiply anything by itself and get 2. But this particular problem factors multiple times. So the couple of curveballs they may throw at you is look for a greatest common factor. Or especially if it's an x to the 4th or an a to the 4th or a y to the 4th or something like that, be aware that you might have a problem that may need to factor more than once, because again, that's why they will tell you to completely factor. Because this is technically correctly factored, but it's not completely factored because this one breaks down some more. Okay, so when they tell you to completely factor, again, they want you to break it down as much as it can possibly be broken down. All right, the last section, last thing we have to cover, what actually finishes up chapter 5 altogether, is actually doing something with the factor. Okay, we're actually going to solve some of these. So factoring is just basically another way to write something. You're taking a product and you're breaking it into its factors. Okay, solving, we're actually figuring out what numbers can I plug in for x that make this whole dang thing work. Now, the reason we can't solve these like a regular equation is if I gave you something like 3x plus 7 equals 13, okay, we can solve for x. Okay, subtract 7 from both sides. 3x would equal 6, divide by 3. All right, x is 2. Great. Okay. If I give you something like x squared plus 6x plus 8 equals 0 and told you to solve this, we can't use our regular techniques because we can't combine our x squared and our x. Remember, you can only add like terms. If I can't combine those, I don't have a way to get the x by itself. I can't use my regular equation solving techniques. So I got to do something different, hence the solve by factoring. Okay. The key to this, the thing that makes this work, one thing you're going to have to do is you have to set it equal to 0. Solving by factoring only works when it adds to get 0 because of this nifty thing called the zero product property. If you're multiplying two things together and you know the answer is 0, then what we know is either A is 0 or B is 0. It has to be. You can't multiply two numbers together and get 0 unless one of them or both of them are 0. Any other number, like if I'm multiplying two numbers and they equal 4, well, I can multiply 1 times 4, or I can multiply 8 times 1/2, or I can multiply, whatever, 20 times 1/5. Okay, so there's a lot of things that can multiply to get 4, but the only thing that multiplies to get 0 is 0 and some number. So step 1, you have to set the whole thing equal to 0. So if there's numbers or letters or anything over here, you got to get them on the other side. Add the opposite to move everything over. Once you have it equal to 0, then you factor, which is what we talked about today, okay, in 5, 4, 5, 5, 5, 6, 5, 7. Okay, so factoring x squared plus 6x plus 8. This one factors pretty easily. X squared is x and x. What multiplies to get 8? That adds to get 6. That would be 4 and 2. So step 1, set the whole thing equal to 0. Step 2, factor. Once you have it factored, this is now your A and your B. So set those equal to 0. So either x plus 4 equals 0 or x plus 2 equals 0. Then solve. So if we subtract 4 from both sides, x equals -4. If we subtract 2 from both sides, x equals -2. And both of those are good solutions. So we have to account for both. If I were to plug -4 in for x, it should equal 0. If I were to plug -2 in for x, it should equal 0. Okay, so what I mean by you can actually check this. So if I plugged -4 in, I can see if that equals 0 like it's supposed to. -4 squared is 16. 6 times -4 is -24. 16 plus 8 is 24. Minus 24 is 0, just like it's supposed to be. -4 is a good solution. Same, if I want to, I can plug -2 in. -2 squared plus 6 times -2 plus 8. 4 plus 8 is 12. Minus 12 is also 0, just like it's supposed to be. So, two possible solutions. Set the whole thing equal to 0, factor, set your factors equal to 0, and solve. Now, when it comes to factoring, they can give you all of the different types of problems that we have factored. So they can give you a trinomial. They can give you a trinomial with a leading coefficient. They can give you perfect squares. They can give you a grouping problem. Okay, you have to be able to solve for all. So for example, let's say they gave us something like 3r cubed plus 6 r squared equals 24r. And they told us to solve. Okay, step one, we got to set this equal to 0, meaning we got to move this 24 over to the other side. So we're going to add a negative 24r to both sides. Now, this is an r cubed, this is an r squared, this is an r. I can't combine any of those. So we just end up with 3 terms. And again, factoring now. So step one, set it equal to 0. Step two is factor. If I'm going to factor this, I want to look for a greatest common factor first. Is there something I can divide out of all of those? Yep, 3 and 6 and 24 are all divisible by 3. And they're all divisible by r. So if I divide that 3r out, I get r squared plus 2r minus 8. Okay, then I want to see if I can factor this anymore. R squared is r times r. And then I'm looking for what multiplies to get negative 8. Adds to get positive 2. That would be positive 4 and negative 2. 4 times negative 2 is your negative 8. 4 plus negative 2 is your 2r. Then you set your factors equal to 0. This particular problem has 3 factors. So we need to set each of those equal to 0. So either 3r is 0 or r plus 4 is 0 or r minus 2 is 0. So take each of your factors and set them equal to 0 and solve. 0 divided by 3 is 0. Subtract 4 from both sides. R could be negative 4, or add 2 to both sides, and r could be positive 2. We end up with 3 possible solutions. Where to go? Okay, one convenient piece of information when dealing with polynomials. If you look at your first exponent, this is a squared problem. We had 2 solutions. We look and this is a cubic problem, power of 3. Guess what? We had 3 solutions. So a key that helps you know how many solutions you're looking for is pay attention to that biggest exponent. Okay, the degree of a polynomial could potentially tell you the number of solutions you are looking for. So that's kind of a key that lets me know I'm looking for 3 different solutions. Okay. All right, to me, this is the trickiest type of problem that they're going to give. If they give us something like this. Okay, x minus 2 times x plus 3 equals 14. Okay, if you pay attention to what we were doing, okay, you go jump to this step. If you look at your factors, we just set our factors equal to 0 and then solve. So some people look at this and they're like, wait a minute, that's already factored. Okay, all I got to do is set those equal to 14 and then we can solve. But that would be bad math. That doesn't work because remember, there's a bunch of numbers you can multiply to get 14. You can multiply 7 and 2, or 14 and 1, or 28 and 1/2. Anyway, lots of things. So remember, step 1, you have to set it equal to 0, meaning you've got to subtract this 14 over here. So actually what we got to do is we got to put these two things together. So I'm going to multiply these. So I get x squared plus 3x plus negative 2x plus negative 6 I'm going to move my 14 over. And I get x squared. 3x and negative 2x is positive 1x. Negative 6 and negative 14 is a negative 20. So if they give you something that doesn't equal 0, remember, you got to get this 14 over here. And when we do that, we got to combine all of this junk into one problem. Now, once we have it set equal to 0, now we can factor and solve. So x squared is x times x. We're looking for what multiplies to get negative 20. That's going to add to get positive 1. That would be positive 5 and negative 4. Okay, I'm not writing down all of the factors of 20. I'm just kind of jumping to the right answer because I need to speed up because we only got like 5 minutes left in class. So I do understand that I'm making the factoring look way easier than it probably is. Okay, but if I listed out all the factors of negative 20, you got 1 and 20, 2 and 10, 4 and 5. Okay, we're going to need one of these to be negative. We want to get a positive one. So anyway, I just quicken that up. Anyway, once you have your factors, set them equal to 0. And then solve. Subtract 5 from both sides. X equals negative 5. Add 4 to both sides. X is positive 4. Okay, so that's basically 5.8. 5.8 doesn't give us any new factoring techniques. It just gives us something to do with it. So again, 5.8, they're going to specifically say, hey, solve. Okay, so remember, the key to solving is it has to equal 0. If it doesn't equal 0, then you can't factor or solve by factoring. Okay, so if they give you a problem that does equal 0, I do think it's nice whenever they give you a problem like this. Okay, if they give you a problem that's already factored and equal to 0, okay, you don't need to multiply those together and then refactor it. Your factors are good. Okay, the problem is it looks like this is already that way, but it doesn't equal 0. So if it already equals 0, good. Just set your factors equal to 0 and solve. Subtract 3. Add 1 to both sides. Divide by 2. Okay, there you go. However, if it doesn't equal 0, you've got to set it equal to 0. So the key is it has to equal 0. From there, factor, then set your factors equal to 0 and solve. Okay, all right, so that's the fun you get to do. Remember, the test is next week, technically tomorrow if you want to do it tomorrow. Okay. Also, the homework on my math lab, hopefully you've been keeping up. That is basically due, I think it's due on the 21st, which should be Thursday. So because you're supposed to technically test Thursday, that's when the homework is due. So if you're waiting to test till next Friday, make sure you have the homework turned in on time. Okay, the homework is due by next Thursday. Okay. Also as a reminder, so this is the number and types of questions we're looking at. So 5.1 and 5.2, you got 6 questions. 5.3, there are 2. 5.4, 3. 5.5 is 4, 2 greatest common factor, 2 grouping. And then stuff we covered tonight, there'll be 3 questions from 5.6, 2 from 5.7, and 4 from 5.8. So this is all the stuff you should be able to do. The test, like I said, will be available hopefully by tomorrow afternoon. So that's what's going to be available. You need to test. So next week is really the testing. So you can, I guess it'll be live tomorrow, but you need to test by next week. So next Thursday, no Zoom because we will be taking the test, and then we'll pick up the next section the following Thursday. Okay. If you don't have any other questions for me, that's all I got. And then we'll see everybody in 2 weeks.
Layla Well, I'm here.
I saw you. I saw
Oh.
you come in. I got you.
Okay, thank you.
No problem. Always good to check, make sure I got you.
Got it. Thank you.
All right, see you, everybody.
So I'm gonna come here next Thursday.
Yes. Yep.
I'll see them.
See ya.
I'm gonna get